So to reduce a radical, I need to, if it's not a perfect square, I need to find my factors. To do this, I'm going to do a factor tree. So my factors of 24 are 2 and 12. My factors of 12 are 2 and 6. My factors of 6 are 2 and 3. Once I have my factors, I want to look for my pairs. Pairs of numbers are going to go on the outside. So this pair of 2's, they become 1 and they go outside. And then I have 2 and 3 that are left alone. Because they're alone, they can't go outside. So I'm going to multiply them back together. 2 times 3 is 6, and then 6 goes inside. And that is my answer. I'm going to do the same thing for 27. I'm going to do my factors of 27. So I have 3 and 9, and then 3 and 3. I have a pair of 3's. So this becomes the 3 on the outside. And this 3 left over, right here, is the 3 on the inside. And that's my answer. Same thing with number 8. I'm going to do my factor tree. So I get 2 and 4, and then 2 and 2 for 4. I have a pair of 2's. This goes on the outside. And I have this 2 that's left alone. He stays inside. Okay. Same thing for 45. I have 5 and 9, and 3 and 3. I have a pair of 3's. They turn into 1 and go outside. And then I have 5 left over on the inside. On number 2, to decide if something is rational or irrational, it depends on what I'm left with at the end. So if something is rational, there are no... Sorry, my pen's not working. Really not working. I'll just get it. Okay. So if it's rational, there are no square roots, and if it's irrational, there is a square root. So if I take a look at letter A, I have the square root of 6 and plus 2. I can't simplify 6 anymore, so I can't add it to the 2. If I look at this expression, it has a radical in it, so that means this is irrational because of the radical. Rational means it looks like a nice whole number. Same thing with B. I want to see if I can simplify this, so I'm going to go do my factor tree for 18. I have 2 and 9, and 3 and 3. I have a pair of 3's, they go outside. And then the 2 is left alone inside. And then I have the plus square root of 2 from the problem. Then what I can do, since they have the same inside, or number under the radical, I can combine the outsides. So remember, this has a secret 1 out front. 3 plus 1 is 4. And then I have 4 square root of 2. Because I still have a square root left over at the end, this one is also irrational. Okay. Letter C. The square root of 9 is 3. Remember, 3 times 3 is 9. That's not my answer. I'm not looking for the answer. Because I was able to get just a number without a radical, this means this one is rational. 4 square root of 2, as we saw in B, was just irrational. And as long as that square root is still there, it cannot be rational. On E, I want a factor tree and see what 72 turns into. So I have 236 and 6 and 6. I have a pair of 6's, so that goes outside. And then I have a 2 left over on the inside. Then, now that I have rewritten it, I still have a radical left over, so this one is going to be irrational. Okay. For F, when I'm multiplying radicals, I can multiply the numbers on the inside. So 3 times 27 is 81. The square root of 81 is 9. So this one is rational. On number 3, I want to solve this by first starting and getting all of my terms on one side of the equation. So having one side equals 0 and all of the pieces of the equation on the other side. what I want to do first is I am going to add 4x and 3 to both sides. So then I get x squared plus 4x plus 3. I can't add any of these things together on the left side because they all have different variables. If they have the same last name, they can go together. If they have different last names, they can't go together. Then on the right side, because I took everything away and canceled it out, I have 0. Now we have a few options for solving. By this point, we've learned solving by square roots, which I cannot do as long as there's a middle term. Solving by factoring, which I can do. I look for what multiplies to the end number and adds to the middle. There's solving by graphing, where I graph this on a calculator without the 0 and see where it crosses the x-axis. And the quadratic formula. Quadratic formula will always work, but on problems like this where I can factor or graph, it probably makes more sense to do one of those, since the quadratic formula takes more time. So I'm going to factor on this question. I'm looking for what multiplies to 3 and adds to 4. So 3 times 1 multiplies to 3, and 3 plus 1 equals 4. My pen is dying. Okay, so once I factor them, I set it equal to 0 again. Then to solve, I want to take each piece and set it equal to 0 because of the 0 product property. So I have x plus 1 equals 0, and then I have x plus 3 equals 0. On my first equation, I'm going to subtract 1 on both sides. I get x equals negative 1. That's one of my answers. And then on the second equation, I want to subtract 3 on both sides, and I get x equals negative 3. Those two are my answers. So what a solution is where it crosses on the x-axis. Number 4 tells me that Henry factors 2x squared minus x minus 6 as 2x plus 3 times the quantity of x minus 2, and that he says the zeros of this equation are located at x equals 1/2 and x equals 2. We want to figure out if Henry correctly got these zeros to this equation. So what I'm going to do is I'm going to take the two pieces that he factored, I'm going to take each of those and set them equal to 0. So I have 2x plus 3 equals 0, and x minus 2 equals 0. On this equation, I'm going to start by subtracting 3 on both sides. I get 2x equals negative 3. Then I divide by 2. And I get x equals negative 3 halves. On the second one, I just add 2 to both sides, and I get x equals 2. So I got negative 3 halves and positive 2. He got positive 1/2 and 2. So he's wrong. And now I'm going to look through my answers to figure out which of the ones he should have picked. If I look at B, it says negative 3 halves and positive 2. That's the choice I want. Okay. Moving on. Okay. Number 5 wants me to factor. I'm going to factor by grouping. So what I do for factoring by grouping is I take my A and C values and I multiply those together. 3 times negative 8 equals negative 24. Remember A, B, C. Then I want to figure out my factors of AC that add to B. So if I take a look, my B value is negative 8. I want to figure out two numbers that multiply to negative 24 and add to a negative 8. So this is going to be negative 12 plus what was I multiplying to? 24 plus 2 equals negative 10. Negative 10 is my middle number. So what I can do now is my B value. Instead of writing negative 10, I'm going to replace it with negative 12 plus 2 because those are two equivalent statements. That means they mean the same thing. So then I have 3x squared, and instead of writing minus 10, I'm going to write minus 12x plus 2x, and then the end part stays the same, so I still have minus 8 at the end. Then what I want to do from here is I want to split this into two groups so I can factor out what they have in common. So if I take a look at my first group, I have 3x squared minus 12x. What I'm going to do here is I'm going to divide both of these by, I'm going to divide both of them by 3x. 3 divides 3 and 3 divides 12, and they will have x's. I'm going to write a 3x out front, and then what I have left over goes inside a set of parentheses. So 3x squared divided by 3x, remember this has a secret exponent of 1. The 3's cancel out, and x squared divided by x1, I subtract my exponents, which just gives me x. On the second one, I have negative 12 divided by 3, which gives me negative 4. The x's on this one cancel out, so I'm just left with x minus 4. If I take a look on the second one, I have 2 and 8. 2 divides 2 and 8, so I'm going to write a 2. Write a 2 in between these two. And then 2x divided by 2. 2's cancel out, and I'm left with 8x. Negative 8 divided by 2 is negative 4. Notice the piece I wrote in pink is the same for both of the factors. So what I'm going to do is I'm going to rewrite this one final time. I'm going to have 3x in one set of parentheses with the 2 out front. I put the 2 outside pieces together, and then the repeated piece goes at the end. Then what I want to do here is I'm going to take each of my factors and set them equal to 0 and solve. So I'll do this as well. So then I have 3x plus 2 equals 0, x minus 4 equals 0. Then I'm going to solve. This is plus 2. I'm going to click minus 1. So then I'm going to subtract 2 on both sides. I get 3x equals 2, divide by 3, x equals 2/3. Over here, I add 4 to both sides, x equals 4. So I'm looking for positive 2/3, positive 4. Just kidding. This was a negative 2. Looking for negative 2/3, positive 4. On number 6, I want to solve this quadratic, but just like number 3 on the front, I need to get it equal to 0. So what I'm going to do is I'm going to add 8x to the sides so that I can get it to equal 0. When I go to add 8x, it can't combine with anything on the left side, so I just rewrite it. I have x squared plus 8x minus 20 equals 0. Then I can use whichever method I want to use to solve. I am going to factor it in. So I'm looking for what multiplies to negative 20 and adds to positive 8. I have negative 2 times positive 10 will give me negative 20. Negative 2 plus 8, negative 10 plus negative 2 plus 10 will give me positive 8. So once I have my factors, I write it like this. Then I'm going to first draw a line to separate my work. Okay. Then I'm going to split up my two pieces, so I have x minus 2 equals 0, and x plus 10 equals 0. Then I solve them. I add 2 on this one. I get x equals 2. And on this one, I subtract 10. I get x equals negative 10. Number 7 wants me to solve the quadratic, and it wants me to give the fraction solution. So what this means is, back on number 5, when I solved it, I had 2 answers. One was a fraction, one was a whole number. It only wants the fraction for number 7. So what I'm going to do is I'm going to solve it the same way. I'm going to first find my AC value. So A, B, C. AC is going to be 4 times negative 3, which is negative 12. I'm looking for what multiplies to negative 12 and adds to 1, which would be... looking for what adds to... So that would be positive 4, negative 3 equals positive 1. 4 minus 3 is 1. Then I'm going to go and I'm going to rewrite this. So I have 4x squared. And then the middle pieces are what are going to change. So instead of being x, it's going to be 4x minus 3x. And then minus 3 at the end, because the end piece always stays the same. Then I go and split it into 2 sections. On the first section, I want to divide out what they have in common. They both have 4, and they both have x's. So 4x is what I'm dividing. I write that out front. And then what I get as my answer, I write in parentheses. 4x squared divided by 4x is just in x, because the 4's cancel out, and I subtract the exponents. 4x divided by 4x, because it's the same thing on the top and bottom, it turns into 1. Then on the second set, I always want to try and make my x's positive, so I'm going to divide by negative 3 on the first and second one. I have negative 3 out front, and then negative 3x divided by negative 3. The negative 3's cancel out, so I'm left with x. Negative 3 divided by negative 3 turns into 1. Then I want to go and rewrite this, so I have the outside numbers together, so I have 4x minus 3 in one set of parentheses, and x plus 1 in the second set. Then what I want to do is I am going to take my two terms in the parentheses, and I'm going to set each of them equal to 0. So I have 4x minus 3 equals 0, and then x plus 1 equals 0. On the first one I add 3, so then I get 4x equals 3. I divide by 4. I get x equals 3/4. This is a fraction. This is the answer I'm looking for. Because I'm looking for the fraction, I don't need to finish the problem. Number 8 is telling me I'm using the falling object formula, which is h equals negative 16t squared plus s. It says if h is ground level and s is the initial height of 270, I need to determine the time it will take to hit the ground, so when it will cross the x-axis. What I'm going to do is I'm going to take 270, and I'm going to plug it in for s in this equation. So I'm going to rewrite it. I have h equals negative 16t squared plus 270. Now what I'm going to do is I need to graph this one to find my answer. I'm actually going to go to Desmos to graph this one. So I'm going to type in my equation. Instead of h, I'm going to use y, and instead of t, I'm going to use x. So I have negative 16x squared plus 270. So if I take a look, it gives me 2 points where it's crossing. It's crossing here on the negative side and here on the positive side. Since I'm talking about something falling from the sky, it makes sense that time goes forward, not that time would go backwards since I dropped something. So I don't care about this answer right here. I only care about this answer right here, which is 4.108. If I go back and look at my paper, I have 4.11, which is my answer because 4.108 rounds, because the number next to 0 is larger than 1. Number 9 is talking about launching an object up. It says that it's modeled by this equation, where h is the height of the rocket after the time that's launched. It wants me to figure out when the rocket will return to the ground. There are 2 ways I can solve this. I can solve by factoring, or I can solve by graphing. I'm actually going to solve this one by factoring. So what I'm going to do is I'm going to rewrite the equation so I can work with it. Then 224 is divisible by 16. I don't know by what though. So I'm going to go on my calculator. I'm going to do 224 divided by 16. It's 14. So then I get, I want to divide both of these by 16t. So I'm going to rewrite this. I have h equals, and then the 16t goes out front because whatever I divide by goes out front. Then in parentheses, I have what's left over. So 224 divided by 16 is 14. And then the t's cancel out. Over here I have negative 16t divided by negative 16t squared divided by 16t. It's going to turn into negative t because the 16's cancel out, but the negative stays, and the t's I subtract by exponents. So then what I'm going to do is I'm going to go back to my equation, and instead of h, I'm going to replace it with 0. So I have 0 equals 16t times 14 minus t. Because these are 2 things, I can split them up. I have 16t equals 0, and 14 minus t equals 0. On this one, I divide by 16, I get t equals 0. This is not my answer, because think about the problem. This girl is standing, and she throws an object, and then it falls back down to the ground. So, it starts in her hand, and then it goes back down to land. On the second equation, though, when I go to solve it, I get negative t equals negative 14. Divide by negative 1. I get t equals 14. This one is number 10. I want to solve this one. This one I would recommend solving by square roots. What I do is basically like solving a normal problem. So I'm going to start by isolating my variable. I add 7 to both sides. I get x squared equals 25. To get rid of a squared, I take the square root. So that turns into x on the left side. But when I take a square root, and I personally draw that square root symbol on the paper, I get a plus and minus sign. So I get plus and minus 5, because the square root of 25 is 5. Number 11 works the same way, except this time I want to start off by dividing both sides by 3. I get x squared equals 18. So then I go and take the square root. Unlike number 10, 18 is not a perfect square. So remember what we did back on the front, I'm going to do my factor tree. So I have 2 and 9, 3 and 3. I took the square root, so it's going to be plus and minus. I have a pair of 3's, so that goes outside. And then I have a 2 that's left over, that goes inside. So my answer on number 11 is A. Number 12 wants me to solve the quadratic equation. Just like 10 and 11, I'm going to start by isolating my variable. I subtract 24 on both sides, I get x squared equals negative 18. Notice, this looks similar to the one we just did on number 11, except it's negative. Whenever I get the x squared completely alone and I have a number on the other side, I cannot have it equal a negative. Because if I try and go and take the square root, nothing times itself will turn negative. So my answer here is no real solution. On number 13, this is putting everything together from 10 through 12, so I'm going to solve. I add 3 to both sides. I get 4x squared equals 64. I divide by 4. I get x squared equals 16. I go to take the square root to get rid of my exponent. This one, it will give me plus and minus 4, but the question only asks for one answer. I can pick positive 4, or I can pick negative 4. I'm going to pick positive 4 just because it's next to me. Number 14 is solving by completing the square, and it wants me to figure out which one is the same as what I had. So to complete the square, I always want to move my number over to the other side, the one without a variable. So I'm going to start by subtracting 2 on both sides, then I have x squared plus 8x equals negative 2. What I'm going to do next is I take my b value, or the number with the x, and I divide that by 2. So 8 divided by 2 is 4. Because it's called completing the square, I need to find a square. I'm going to take the number I just got, 4, and I'm going to square it. 4 squared is 16. This is my magic number. This is the number I'm going to add to both sides. So I have x squared plus 8x, that part stayed the same. Now I'm going to add 16 to the left, and I'm going to add 16 to the right. Remember, whatever I do to one side of the equation, I have to do to the other, because I have to keep the equation balanced. Next, I want to figure out what multiplies to 16 and adds to 8. Hint, it will always be this number I found when I divided by 2. So I'm going to have x plus 4, and then I get a squared, because it's completing the square. On the right side, I just have to simplify. So negative 2 plus 16 is the same as 16 minus 2, or 14. This is as far as they got in their work, so all I have to do is find the equation that matches, which is B. Okay. Number 15 is a little bit easier. I don't have to go as far in the process. It wants to figure out what number I need to add to both sides to complete the square. So I'm going to take my b value, which is 4. I'm going to divide by 2, which is 2. To complete the square, I need to square that answer I just got. So 2 squared is 4. So number 15, I would want to add 4 to both sides. Number 16 wants me to write in standard form. I am going to do this, I want it to go x squared x numbered. So since my x is on the other side, I'm just going to add it to both sides. I have 4x squared plus 8x plus 3 equals 0. Then a, b, and c. So a is 4, b is 8, c is 3. Number 17, I messed up. We're not going to solve this. 18 is wanting me to solve the quadratic. What I'm going to do here is use the quadratic formula. So So that's x equals negative b plus and minus the square root b squared minus 4ac. All of this is over 2a. So if I go back to my equation, I have a, b, c. My a is 1, my b is negative 6, and my c is 3. I'm going to take those three values and plug that into the equation I just wrote on the left. So now I have x equals negative 6. Whenever I plug in a number, I listen to the sign on the paper, but I keep the sign that it has, so I have a double negative right now. Then I have plus or minus. Negative 6 squared. Whenever I write a number to be squared, I write it in parentheses because the negative belongs with the number. Then I will do minus 4 because that's part of the formula. And then my a value is 1, my c value is 3. On the bottom of my fraction, I have 2 times my a value of 1. And what I want to do from here is I want to simplify. So I have negative 6, that turns into positive 6. Then I have plus or minus, that doesn't change. Negative 6 squared is the same thing as positive 6 squared, which is 6 times 6, which gives me 36. Negative 4 times 1 is negative 4. Negative 4 times 3 is negative 12. 2 times 1 is 2. Then what I want to do next is I want to simplify the numbers inside the radical. So 36 minus 12 is 24. Notice 24 is not a perfect square, but I can do the factor tree. So I'm going to look for my factors of 24. I have 2 and 12, 2 and 6, 2 and 3. It's not on the screen anymore. Okay. I have a pair of 2's. So what I'm going to do, I'm going to go back to x equals. I still have 6 on top. Now I can pull out a 2. I just circled those. Inside the square root, I have the leftover numbers, which are 2 and 3. 2 times 3 is 6. And on the bottom, I still have 2. So what I can do is I can divide each thing by 2. I'm going to split this up. It's going to be 6 over 2 plus or minus 2 square root of 6 over 2. The square root does not get its own fraction because it is being multiplied to the 2, and you only split when it's adding or subtracting. So I can divide 6 by 2. It's 3. 2 divided by 2 cancels out, and I just have the square root of 6. So my answer here is positive 3 plus or minus the square root of 6, which is number 19 wants me to solve the quadratic. I need to use the quadratic formula again. I'll write that up like that. So my a value here is 1, my b value is negative 5, and my c is negative 17. I'm going to put this in. I have x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative 17. Then on the bottom, I'm going to have 2 times my a value, which was, I'm going to simplify. Negative 5 turns into positive 5. Negative 5 squared turns into 25. Negative 4 times 1 is negative 4. And then I'm going to do negative 4 times 17. I'll that one in that one. Which turns into positive 68. So 25 plus 68. On the bottom I have 2 times 1, which turns into 2. Then if I keep rewriting it, I'm going to get 5 plus or minus 25 plus 68. Which is off the screen because of the glare. 93. So I get 5 plus or minus the square root of 93 over 2. So now I just got a match, which is my first choice. Number 2, nope, that's not a 2. Number 20 can be solved the same way. I'm going to do the quadratic formula. A is 2, B is negative 3, C is negative 13. I'm going to plug in. I have x equals negative 3 plus and minus negative 3 squared minus 4 times 2 times negative 13 over 2 times 2. So then I want to go and simplify. Negative negative 3 is positive 3. Plus and minus negative 3 squared is 9. Negative 4 times 2 is negative 8. And then I gotta figure out what negative 8 times negative 15 is. Positive 104. On the bottom, I get 2 times 2, which is 4. Then I'm going to rewrite it again. I have 3 plus or minus the square root of 113 over 4. 113 is prime. It means I cannot factor it anymore, so this is my answer. Number 21 wants me to find the solution of the system. This means graph them and say where it crosses. It only wants one solution, so I only need to say one of the points where it crosses. What I'm going to do is on my calculator, I go to y equals. If there's any equation here, I want to clear it out. I don't have any, so I just type in my equation. Oops, this one's plus 1. And the bottom one is x squared minus 1. I go and graph this. My window's wrong. Okay, so now that I've fixed the problem with my calculator, we're looking for where they cross. So it crosses right here. Rather than just try and guess, what I'm going to do is I'm going to press the blue second button, and then I'm going to press the trace button. And then I'm looking for where they cross. Another word for cross is intersect, so I'm going to pick choice 5. The first time I press enter is to pick the blue line. The second time I press enter is to pick the red line. And the third time is because it thinks it's fun to guess. I just press enter, and it will tell me my answer. This is kind of hard to read. It says negative 0.449 for my x and negative 0.798 for my y. I want to round to 3 decimal places, and I am good. Number 22 wants me to see if these students are correct. It says they've been given the equation, x squared plus 1 equals x plus 1, and they need to determine which values of x were. So if I look, it's kind of hard to see on this graph, so I'll, in pink, draw where the grid line is. So that's the grid line. So this point right here, where it first touches, is 0, 1, and the second point where it touches is 1, 2. So student 1 is saying that for x values 0 and 1, it crosses the 2 lines. This is true. They are correct. Student number 2 says it crosses at negative 1. Over at negative 1 is where the line is crossing the x-axis, not where the 2 equations are crossing. On number 3, they say at 1 and 3, they're not even touching at negative 1. I mean, where did I get the 3 from? Negative 1 and positive 1. As we just discussed, they're not touching at negative 1, so they're also, well, not really.